Welcome back to my channel, everyone. 3 tips here. What I have is some Karat gold that we're going to refine. We're going to begin by adding the 14K material into our melt dish. And then I've got some 10K stuff I'm going to put in here. And then now I've got some 18K stuff and a few pieces of pure gold powder that bounced out of the melt dish in a previous video. I'm going to add this in. And what I'll have in there is this much Karat scrap. I determined I need 217 grams of sterling silver, 213 actually, but I've got 217 here. And now what we'll do is we'll melt this gold and quart it with silver, and then we'll proceed from there. Okay, here we go. We're going to start melting the gold now. Rinsed the quarted gold off with some distilled water, transferred it to this 2-liter beaker, and now that we've got the gold concentration in this alloy down around 25%, we can now use dilute nitric acid to pull all the silver that we just added, plus any silver and base metals that was already in the alloy of the Karat scrap. So now we're going to do nitric acid boils and pull all the silver and base metals out. We'll set this up on the heat and let this react. Got all the silver and base metals pulled out now. I'm going to dump off this nitric acid into my silver jar. And then what we'll do add some hydrochloric acid to this. Now this hydrochloric acid will react immediately because there's going to be some residual nitric acid in here. That's about 400 milliliters of nitric or hydrochloric acid going in. Then I've got some nitric acid right here. We'll start adding small doses of this in. get all this gold to dissolve. I'm going to turn the heat off now. I've got all the excess nitrate driven out of here. I've seen some soft solder repairs, some of the Karat gold that I incorporated with silver. That means lead. So I had to dissolve this so I could add some sulfuric acid and precipitate out the lead. I've allowed this to cool completely. I've calculated the estimated yield for this lot. Should be about 105 grams of pure gold. So now what we're going to do is, oh yeah, I can see some stuff down in the bottom of the beaker there. That's probably the lead that got precipitated when I added the sulfuric acid. Sulfuric acid will react with any lead in solution that's in here with the gold, form insoluble lead sulfate, and then that settles to the bottom here. Now we're going to go ahead and ice this down, and if there's any silver in here, it should come out of solution with the when I add these pieces of ice. My original intent was to pull the silver and base metals out with those nitric boils and then make an anode bar out of the incorporated gold that I recovered from that. What do we got going on? I forgot to turn the vacuum on. My original intent was to melt the recovered gold from the incorporation process into an anode and then run that through the electrolytic cell. But I seen soft solder repairs. See that stuff up in there? That is our lead sulfate that's been precipitated out with the sulfuric acid. I seen soft solder repairs on the Karat gold. Soft solder contains lead. So that's why I chose to dissolve the gold with aqua regia so we could add some sulfuric acid and get this insoluble lead sulfate filtered out of the gold. Lead in just tiny trace amounts ruins the ductility and malleability of the gold. So it has to be removed first. That's why we did this aqua regia refining. See that orange colored material? That's the lead sulfate. Lead sulfate is normally white, but it's mixed with that gold chloride solution. That's the lead from the solder that was on the Karat scrap. Got it out of there now. The solution still looks a little cloudy, so what I'm going to do is we're going to pass this through the same filter a second time. Try to get a little bit more cloudiness out of there. Paper failed. much better. And if you look in this filter, you can see that orange material is the insoluble lead sulfate. Precipitate out pure gold with some stump out. Start adding the stump out right on in. Here we go. I'd like to point out there were some small pieces of pure gold down in the bottom of this beaker. I had used it previously, and a few crumbs of gold fell off in there. That's what you see down at the bottom of this beaker. Let's get a stannous test. I can see by the yellow color there's still gold in solution. So now what we need to do is go ahead and add some more of our stump out to get the rest of this gold to come out of solution. I can tell by the color that we've got all the gold to drop out now. We're just going to let this settle out. Then I'll make an anode bar out of it. I've allowed the gold to settle. And now what we're going to do is pour off this waste solution. Do is transfer the gold into this filter paper. Let's see if I can get a shot of this. Oh, jeez. Of course. What a mess. do is transfer the gold into this melt dish, filter paper and all. Let's see if we can get it in here. It's going to be very close, man. That's a lot of gold. And I don't know if I'm going to get that in there. Melt dish is too small for this job. Spilled a few crumbs of gold. I'll get that up later. Let's take our gold over here to the melt table. What we'll do is melt this an anode bar. What I've got is a small piece of 14K gold, and I kind of bent it so it sits in the mold up off the floor of the mold. So what we'll do is we'll melt the gold. I'm going to heat this cavity with a torch, and then just before we pour this gold in, I'll add this piece, get it heated up, and hopefully the bar will weld to this piece, and then we can use it to hang our bar in the gold cell. It was a fail. This thing was too thin and it melted instead of bonding to the bar. Got to start all over. Let's go ahead and cut the stem off of this shark's tooth. I've got a hook fashioned out of that piece of stem from the previous refining that we did. And so what we're going to do is go ahead and try this again. that did it. Oh yeah, it's in there real good. Here's our anode bar. Now what we need to do is set the cell up. I'll begin by filtering the electrolyte. This is from the previous experiment. A little bit of a mock assembly here. And use the same cathode as last time. This time I think what I'll do is place the anode a little closer to the cathode. The depth looks okay. So now what we'll do is go ahead and add the electrolyte into the cell. Adding some heat. Need to get to 140 degrees in our electrolyte. I've got the solution heating up. Starting the time lapse. As soon as we get up to 140 degrees, I'll energize the power supply. We'll commence the refining. We're up to temperature. Turn the voltage all the way down. Amps all the way up. Now we're going to energize our power supply. We're going to adjust this to 1.5 volts. There we go. We should start seeing some action on our cathode. Our electrolytic gold refining cell. If you look closely, you can see the little density of material coming off the bottom of that anode. It's kind of neat looking. Our refining is complete. Now what we'll do is go ahead and turn down the voltage all the way to 0. Kill the power supply. And now what I'll do is reach in here, grab the anode. I'm going to stick it in some water. Another shark's tooth. Turn the heat off. Now we'll disconnect the cathode. And then we'll pull the cell down off the heat. Reach in here and grab the cathode that's got our gold on it. Looks spectacular. our final product. This is our high purity gold. 4/9 fine. Pure gold crystal. Looks fantastic. Let's go ahead and get the electrolyte off of here. What I'll do is just add it right into my waste container. Adding some distilled water, and we'll put it up here on the heat, boil it in some distilled water for a little while, see if we can get all that electrolyte off of there. All right, let's get the gold out of here, get it down into a clean beaker, and now what we'll try to do is scrape this off of here. It's coming off fairly easy. Right. There we go. Get it off the back. Might have to work on that a little bit later. Let's just go ahead and work with what we've got down in our beaker now. Take the gold over to the melt table now. Look at that stuff, man. Take it over here to the melt table. And we'll try to melt this up and ingot. Here we go. Here's our pure gold bar that we just melted. tell you the truth, it doesn't look a whole lot different than the 3/9 bars that I refined with Aqua Regia and SMB. But we're expecting, what, 105 grams. I've got 91.4. I've got the shark's tooth from that one right here. And then we've got the other shark's tooth from the refining that we did the other day. So this will conclude the video. I was able to do this in about 24 hours time. Go from Karat scrap to 4/9 gold bar in about 24 hours. That'll conclude the video. Thank you for watching.